Good morning, my Algebra 2 students, or good evening. What we are looking at today is something called polynomial long division. So I had asked you guys in class, did you remember how to do long division? And here's the day why. So some quick intro into it. If we take a particular polynomial and we work it back into factored form, what that means is that we could have taken the quotient given one factor to produce the other. So like a really easy example of that, with this one, if you divide by the factor of 5, it produces the other factor of 3. Easy. So if we use that and put it into play here, think about what this factors into. What adds to 6 and multiplies to 8 would be x, and then plus 4 and plus 2. So with that same logic, it would go to show that if we did x squared plus 6x plus 8, and we divide it by one of these factors, so let's say x plus 4, then what it should produce would be x plus 2. Excuse me. And in this particular case, then we could find what the roots are. They would be -2 and -4 if we set each of those equal to 0. All right, for this next one, now we have a cubic function. So what we're looking at is what two factors would it break into? And then if we look over here, they've given us one of the roots. So if the root is x equals 2, we know as a factor that that's x minus 2. The question is, what is this part going to look like? All right, but this comes from the root x equals 2. Just want to make sure that that's clear. So what our goal is rather than going here first, let's come over here and take x cubed plus x squared minus 10x plus 8. And if we can divide it by that factor of x minus 2, that'll get us the answer that we need over here. To be able to do this, here's where long division comes in, because we are dividing the polynomial by one of its factors. So as a little reminder, let's call it a little like old school long division. If I give you an example, so not this, but let's just pick a number. If we go like 2,187 divided by 9, because we have to have something that can show the process. We would put this here, and then the 9 would go in front. And then what you would run through is that process of reminding yourself, all right, does 9 go into the first digit of 2? No. All right, can we divide 9 into 21? Well, yeah, how many times? We can divide 9 in twice, and then 9 times 2 is 18. When we subtract, we're left with 3, and then we bring down the next digit. So if we bring down 8, then we do it again. How many times does 9 go into 38? 4 times. So 4 times 9 would be 36. We take the difference and we keep running. I hope this is coming back to you here. Then we bring down the 7. How many times does 9 go into 27? Well, 3. So 9 times 3 is 27. We get 0. Yay, we did it. So what that actually means, not only that 9 is a factor of 2,187, but it means that we can write 9 times 243, and that's the same thing as this. So that's the goal of what we're looking for here, is can we divide it out to then figure out what the factors are? All right, I hope you left yourself some space over here. Now let's take a look at this in terms of polynomial division. Now, if you have another color, like a red or just a colored pencil, something like that, I think it'd actually be super helpful right here, all right? To set this up, underneath the division sign here, we're going to have our x cubed plus x squared minus 10x plus 8. And then over here, we're going to divide in x minus 2. All right, what you need to focus on here, just like when we would look at this and say, hey, does 9 go into 21? I want you to look at this, the first term of it. That's where you're going to bring your focus and say, all right, does x divide nicely into x cubed? Well, yes, it does. All right. But does x minus 2 go into this? No. So technically we look at the whole thing here, but don't overthink that. All right. How I want to deal with this is x times what would give me x cubed. Well, that would have to be an x squared. So what's going to go up top is an x squared, and then we're going to multiply that through here. So x squared times x will give me x cubed. X squared times -2 would give me minus 2x squared. This is where I wanted you to have the colored pencil. The next step when you're doing division is you're going to subtract it. I have to make sure that I subtract both of these terms. So subtract the x cubed and subtract the 2x squared. These will cancel. That's what we expected them to do. Here, this is going to flip the sign. And so x squared plus 2x squared turns into 3x squared. All right. We bring down the next term of minus 10x, but we focus on the first part. Let's try it again. X times what goes in, or would give me 3x squared? Well, up top would need to be a 3x and a positive one in that case. So when I multiply, 3x times x gives me 3x squared. 3x times -2 would give me minus 6x. Now we need to subtract both of those terms. So subtract here, subtract here. All right, that cancels, which is what it should do. This again will flip to plus a positive. And so -10x plus 6x, that's going to give me -4x. All right, finally, bring down that last term. And let's take a look at the leading term here. All right, x times what would give me -4x? Well, that would need to be a -4. So when I do -4 times x, I get the -4x I wanted. -4 times -2 gives me +8. And then remind yourself, you're subtracting both. So subtract this, subtract this. That flips to plus a positive, which perfectly cancels on out. +8 minus 8, that cancels on out, and I get 0. So again, when the remainder is 0, that means it divided in perfectly. So for us, what this means here, I can do a little 3 dots for therefore. Hopefully remember that from years prior. X minus 2 is a factor. Yay. And so what that means for us is that we can write it as x minus 2 times the quotient that we got up here, the x squared plus 3x minus 4, and that's equal to the original, to that x cubed plus x squared minus 10x plus 8. So I just want to make sure that we understand that that's what that actually means, that if we multiplied them back out, it'd come out to here. All right, let's take a quick pause and go back up to that chart. That means that up here in the chart, that this is x squared plus 3x minus 4. And over here, it's x squared plus 3x minus 4. Because if that's the product, then that should be the quotient there. But it's asking for the other two roots. So what that means is we should be able to factor further. So if we come down here and take a look, this, if we think of it as a little add multiply guy, factors beautifully. This, we're going to have x and x, and then 4 and 1. This needs to be a plus and then a minus. And then if we set it equal to 0, there's that root that we're given. Here's -4, and then +1. So those are all the roots or the x-intercepts of that cubic function. So back into your chart, feel free to fill in those last two values. So then -4 and then plain old 1. All right, hopefully your head is not exploding and you're like, long division, what? But let's try it again. So when you flip on over to the next page, sometimes the repetition will help. All right, there's 2 more quick long divisions with just numbers. So let's run that practice again. So if we take 1,519 divided by 7. All right, if it doesn't go into the first digit, then we look at the first 2. It goes in twice. That'll give you 14. Subtract, you get 1. Bring down the 1. Goes in once. Subtract. We're left with 4. Bring down the 9. That goes in 7 times. Subtract, we get 0. So that means it divided in perfectly. If you have something like the next one, where it's 1,522 divided by 7. Well, you probably are starting to suspect that, wait, 1519, 1522, this one's not going to work. But let's remind ourselves of what does happen. So that would divide, you bring this down. It'll go in once, which is 7. We get a difference of 5. Bring it down, it goes in 7 times. We get 49, and then that little 3 right there, that is our remainder. Now, when you first learn long division, we would put this up here as R3, a little remainder 3. What it needs to mean for us today, first of all, is that 7 is not a factor of 1,522. And then rather than writing remainder 3, what it actually means is that it's 2,117 and then 3/7, because 7 is what you were dividing by. So that's how we would write that as an actual answer versus turning it into some crazy decimal. All right, so it's a fractional exact answer there. So hold on to those thoughts as we go into this next one. Let's go back to polynomial division. So with this first one here, set it up. So 2x squared plus 15x plus 20, and you're going to divide it by x plus 6. All right. Focus on the first term. All I meant by you have to think about the two terms is you're not supposed to line it up here. Technically, you line it up here. It doesn't matter that much to me. All I want you to think of is, all right, does x divide nicely into 2x squared? Yes. What would you need up here to make that happen? Well, I need a 2x. So if I put a 2x up top and then I multiply it through, whoops, maybe I'll use my blue pen here. That's going to give me 2x squared. This will give me 12x. And then remind yourself, you're subtracting not just the first part, but both parts. That cancels. 15x minus 12x, that's going to come down as a 3x. And then bring down the plus 20. All right, look at the leading term. X times what do I need to have to give me 3x? So that needs to be x, and then times 3. So this will give me 3x. That would give me 18 because I'm distributing it through both of those pieces. And then I'm subtracting both parts. So if I subtract 3x, subtract the 18, this cancels. If that first term doesn't cancel, then you didn't do it right. Go back here and fix it. Otherwise, you might be left with something there. So this is our remainder. What that means for us is if the remainder is not equal to 0, then it's not a factor. So we could say that x plus 6 is not a factor of the 2x squared plus 15x plus 20. So we couldn't break it down and factor it into two parts and so on, all right? The other thing that means is that means if x plus 6 is not a factor, then x plus 6 equals 0. X equals negative 6 is not a root or an x-intercept. So I can extend it to that idea. And that's important as well for what we're looking at today. Right? So the one next to it, when it says let's do 2x squared plus 15x plus 18 divided by x plus 6, if we set up that same problem, what you might notice, right, is that this one should work. Because if we look up top, we would have the same 2x. This would give me 2x squared. This would give me the 12x. So take the difference. That'll give me 3x. And then bring this on down. Now it matches. So up top would go 3. I would get 3x plus 18. There's my difference of 0. Right? I think using the red pen helps. If you can go through it without, feel free. But I definitely think for the first few that it's super helpful. All right. So what that means in this case is that that is a factor, and that x plus 6 times 2x plus 3 is what 2x squared plus 15x plus 18 should factor down into. All right, let's try it with some larger polynomials. So we're only going to do one or two more, and then we'll leave the rest for the next time I see you in class. So this one here, let's try it on out. We have 8x cubed and so on. So set it up, make sure to leave some space above. So 8x cubed plus 10x squared plus 23x minus 25. All right, and in front needs to go 2x minus 3. All right, again, focus on those first two leading terms there. So what needs to go up top so that when I multiply it by 2x, I'll get 8x cubed? That's what you have to ask yourself. Hopefully you're coming out with a 4x squared. So distribute that through. This gives me 8x cubed. 4x squared times negative 3 gives me minus 12x squared. And then remember, you're subtracting both. So you're subtracting here, you're subtracting here, which ultimately flips the sign. So 10x squared plus 12x squared. Oops, I just realized that I had a copy error there. Sorry about that. Sometimes I catch my little mistakes, sometimes I don't. Oops, that is a minus. There we go. Okay, so minus 10 plus 2. That's going to give us then a 2x squared. That was a close one. All right, bring this on down. So plus 23x. And now play the game again. So look at your leading term. 2x times what would give you 2x squared? Well, all I need is just a single x up top. So x times 2x is 2x squared. X times minus 3, that's going to give me minus 3x. All right, you're subtracting each part. So flip those signs. Minus, that essentially turns into plus. This will be gone. This comes out 26x. All right, bring on down that minus 25. Last time. All right, we've got 26x and 2x. Up top, we need a positive 13 to make this happen. 13 times 2 gives us 26x. 13 times negative 3. That'll give me minus 39. All right, subtract each part. So subtract, flip, that'll change there. And then when you add it together, negative 25 plus 39, I get 14. So what should be really evident is that 2x minus 3 is not a factor of this, but then how you would write the actual answer. If it just says divide and tell me what the quotient is, then it would be 4x squared plus x plus 13. And that remainder of 14, we would add it on as 14, but then out of 2x minus 3 right there. That would be the actual answer. All right. I think the rest are actually great to save for class for tomorrow. So write a little note that we'll get to those then. See you guys soon.